Awesome, cool. Can you hear me fine, everybody? Yeah? OK, cool, awesome. I'm super excited to be with you here. It's awesome to see so many Elixir fans in one place. I must say I missed this. So it's great to have you here. And everybody joining virtually, hello. Cool to have you there. As Joanna mentioned in today's inspiring keynote, observability is super important for production apps, right? And you might need that either, like it was in the case of Duffel, when you're doing load testing and you kind of need to figure out where it's going wrong. Or, for example, when you probably had that in the past, like you write this endpoint and it all works fine in dev, and then you kind of ship it, and your customers try to use it in weird ways that start taking a long time to load. And they're sending you tickets saying, hey, this is not loading. And you did all the preloads and everything in Ecto, but it's still not working for some reason. So in those cases, you wish you had more insight into how the endpoint is working, what's actually taking so long underneath, right? So that's when you need observability. So today we'll be talking about one tool that kind of solves part of the observability problem, which is Open Telemetry. Okay. Click. First of all, who am I? So I'm Kamil Kowalski. I'm a lead architect at Fresha. Fresha is a startup in the beauty and wellness space. So we build business software for salons and spas to organize their work, and then we built a marketplace on top of that for end customers to book visits at those salons. We use Elixir heavily at the back end. We run a lot of services, and last year we had this period where we started having weird issues and incidents. And we said, like, boy, I wish I could know what's happening here. So since last year, or even more than that, we've been investing heavily into observability. That's when I kind of got interested in the topic and dug deeper. So for today, we're going to talk about a couple of things. First of all, we'll talk about what is OpenTelemetry, then what it is not. Then we'll talk about how does it differ from stuff that you might have seen previously. What are the core components of OpenTelemetry, so you kind of understand how it all fits together. And then we'll do a live demo, yay. And then we'll talk about, I'll try to answer the question that would probably appear after the talk are we there yet? Like, is it production ready, or can we use it, or what? OK, so first of all, what is OpenTelemetry? So I copied the definition. Okay, it's a set of APIs, SDKs, tooling, and integrations that are designed for the creation and management of telemetry data, such as traces, metrics, and logs. So let's break that down. Over time, the three main ways we figured out to observe our apps are basically the traces, metrics, and logs. Traces are collections of spans. Trace is a collection of spans that measure the execution time of a piece of code. Basically, that's the gist of it. Metrics, these are like numbers associated with some label. So you could have a metric saying, like, what's the average query time or something like that. That's a metric, right? And logs, you see those in the console. So OpenTelemetry is actually not anything totally new. It was created after the merger of two other projects that you might have heard of, Open Census and Open Tracing. And they kind of saw that they have the same mission for the libraries for the project. So they kind of decided, OK, let's merge this into OpenTelemetry. OpenTelemetry is now part of the Cloud Native Computing Foundation. And since August 26th, it's incubating. So previously, it was in Sandbox. Now it's incubating, which means that the foundation kind of deems it a pretty stable project. It's there up with gRPC, Argo CD, all these kind of projects in incubating mode. And the kind of the vision for OpenTelemetry is a world where application creators can basically create the app and they get instrumentation out of the box, right? How cool would that be? Like, you just write the code and you get your app instrumented. You see all the queries, everything that's going underneath, and you can dig deeper. You can kind of explore what's taking so long, why is it the system behaving this way and not the other way. So that's a pretty cool vision. I really love that vision. What it is not, so it's not an APM solution, you might have, APM is a tricky definition anyway, but you might have seen like APM solutions, for example, AppSignal, Datadog as an APM, New Relic, right? And they're mostly around traces. So OpenTelemetry is not an APM solution because it doesn't provide any way to visualize the data. It's just a standard of getting that data, aggregating it, transforming, sending it over, and it just standardizes it across languages. It's not a tool that you can visualize the data in. You need another tool for that. So it will not solve that. So it's also not a replacement for telemetry. So you might know the awesome telemetry project, which is already kind of adopted by Phoenix, by Ecto. And it's not telemetry. It's not a replacement. It's something that can work with telemetry pretty well. Okay. So how does it differ from previous work? First of all, we used to have tools that, for example, did log aggregation well, or did or did traces and metrics, but didn't do logs and everything like that. OpenTelemetry covers the entire spectrum, so it defines a standard of trace aggregation, metrics, and logs. Right. Another important way it differs from stuff that we saw in the past is that it separates the API from the SDK. And I'm going to take a bit more time to explain that because it's crucial to the idea behind the project. So the API in OpenTelemetry, it's basically a library that allows us to instrument the code. So a library that allows us to define, like, where are the traces. So imagine you have Phoenix, right? You are the creator of Phoenix, or maintainer or developer of the Phoenix framework or library. You can put API calls in that library that will basically say, OK, this part of the code, for example, the part where the controller action is being executed, that's interesting from an observability perspective. So wrap that in a trace or a span. But the API calls themselves, they are just hints. Like they say, OK, maybe this is interesting. Maybe that is interesting. But what actually starts the observability is the SDK. So the SDK is a separate piece of software that basically kind of fetches the data from the API calls across your system. It transforms it, and it sends it somewhere, like outside of the app. And you need the SDK probably in the applications that you're going to deploy. You can use the API in your applications that you're going to deploy, and you definitely want to use the API in libraries that you're creating. Okay, so this is in stark contrast to previous work that you might see in where the library that allows you to define a trace, for example, you need to configure that library with an endpoint or with an API key if it's a proprietary solution, and then that makes it impossible to use in other libraries, right, or difficult. It's also language agnostic. So some of the observability solutions that we saw in the past, they said they support Ruby and Elixir, or they support Java and, I don't know, JavaScript, because it's mostly the same. No. And they didn't cover the full spectrum, right? So this is a standard that is language agnostic. It basically can be implemented in any language. They try to make it as easy as possible to be implementable in other languages. Let's look at the components of OpenTelemetry. So here's a example instant messenger platform. We have two backend apps. Messaging server is written in Elixir, and then the media service is written in Node. The messaging service uses a database driver library, also in Elixir. And that's all. And so the components in blue are basically parts of OpenTelemetry. So first of all, on the left, we have the OpenTelemetry specification. The specification defines how to build API and SDK libraries for any language. So it defines how they should work, what are their capabilities, so to speak, but in a language-agnostic way. And it also defines the data that you want to gather in these libraries. So how is a trace built up? How is a span built up? The specification went 1.0. It's basically stable since the beginning of the year, this year. So that's pretty awesome. And then we have implementations of the spec. So we have for example, the Elixir API, right? So that's for the language. For Elixir, we built an API library that allows us to instrument the app. It's the same for Node. There's a Node.js API, and there's also an SDK, Node.js SDK, Elixir SDK. And as you can see on the top, the library just uses the API because it basically will hint at the application that's using the library that, hey, listen, I got this data that might be interesting for you. You might want to consume that, but you might not. Then the data is sent by the SDK to somewhere. Like in this diagram, it's being sent to the collector. The collector is actually an app built in the project. It's written in Golang, I believe, and you can deploy it on your host or as a separate service in Kubernetes. It gathers data from your apps and it sends them somewhere else. Like it can export them, sending it to another system in OpenTelemetry, it means exporting. So the things that send the data, they are called exporters. So it can export the data to, for example, an observability suite like Grafana, Datadog, whatever. And internally, the SDK and the collector, they communicate via the Open Telemetry protocol, which is also part of the project. It's a set of basically protofiles that define all the interesting data. So that's pretty neat because then you can use them across languages. So let's show a demo. So the goal for my talk today is to kind of get you excited. This is not going to be a super deep dive. If you want to do that, there's the scope is pretty huge of OpenTelemetry. So I want to kind of show you what's the end result. What can you build with it? How can you use it? How would it be useful for you? Gotta kind of get you excited about the technology. So you can maybe start adopting it, trying it out. So the library creators get more info from you. Or even contributing to it. Like there's a lot of stuff that should be built around OpenTelemetry to reach its vision. So we're going to build something. We're going to instrument something super exciting, right? So it's a CMS solution. But it's actually, by CMS, what I mean by CMS is a chicken management system. So chickens approached me and they told me, like, listen, Kamil, we have this egg factory, and we have this old system. It's called the Time Tracker, and they've been using that system to kind of track time, to clock in, clock out of the egg factory. And they wanted another piece of that system to be built. They wanted actually to build the hatchery management system into that, whatever. But they didn't want to remove the time tracker system because it is working, so why refactor, why rewrite? So they wanted to use that as a microservice, basically. The demo, by the way, is available here, so if you want to kind of test it out. It uses Docker, so the only thing you need to do is have Docker running. And I think one Docker plugin is needed for Loki. So all in all, it looks like this. So for now, like chickens are going to use the CMS system. That's going to be a Phoenix app. And it's using a Postgres database. And it's going to be calling the time tracker app, which is old, but is working, so let's not change it, over a JSON API. The neat thing about the time tracker app is that it's already instrumented. So if we just talk to it, it's going to work out of the box. So let's just focus on the Phoenix app. Okay. So let's just first see how it looks. So the app looks like this. Okay, it's called What the Cluck, and you can cluck in because chickens, humor, and you can click here. You clucked in successfully. There's no clock out. I don't know why. Ask the chickens. There's also an egg inventory, so you can kind of add a new egg as incubating. Voila. So that's the part using the Postgres, right? In code, it looks like this. So first of all, we have, there's a README. You can follow the README. I'm going to follow it because I couldn't type it in. Too stressed. So there's a README if you want to follow. There's a compose file here. It kind of defines all the services. There's a DB service, Grafana, log key for, so Grafana is used for visualizing data, right? Metrics and traces. Log key is for aggregating logs. Tempo is used, it's a Grafana project as well, pretty new. It's used for visualizing and aggregating traces. And two of our apps, CMS and Time Tracker. Pretty simple, plus some configuration. We're not going to go into the Time Tracker. The CMS app is a standard Phoenix app. There's a web context. That's not interesting. There's a CMS, the core context, and there's a hatchery for egg management. So that's that's just boilerplate, list eggs, all that. And there's also a time tracking module, which actually calls a client right to clock in. So there's a function called clock in. It calls a client. If we kind of open the client, it's using Tesla under the hood, right? So it's going to perform a HTTP request to the time tracker app. So let's start. First of all, let's maybe kill the process in. By the way, I'm using some aliases. Maybe I'll show you the aliases. So DKC, that will mean Docker Compose. DKCU, that's Docker Compose up-d. And I'm using logs somewhere. So if you see these aliases, so you are not confused. So we'll stop the CMS so we can work on it locally. Enter here. And first of all, what we'll do is, sorry, I need to rearrange. I need to be closer to the terminal. First of all, what we will do is actually install the SDK so we can see if any data would be collected. So that's the library is called Open Telemetry. This is the SDK. It doesn't have a SDK suffix, sorry. So let's add that to our dependencies. And then we need to configure the SDK. So the SDK is an Erlang app, basically, called Open Telemetry. And we will configure its processors. Processors, basically, they process the data that's gathered by Open Telemetry API. So we'll use the batch processor with a std out exporter. It's going to export the data into std out. So let's do that in dev. Boop. And let's do mix deps get. And I hope I have internet. OK. Let's run Phoenix. So we compiled. Should be running. Yeah, you see it's dev because we got the live dashboard link. That's available. I left that out. That's available because of dev. And you can see in the logs that we start getting these spans for debug message. And that's actually the std out exporter trying to export data. But it doesn't have anything yet because even if we walk around, clock in, it doesn't have anything to export because we are not instrumenting the app yet. Like we only installed the SDK. So let's instrument the app, our app now. And fortunately, like as I said, the vision is so that we can just install the tools we want to use and have the app instrumented out of the box. So fortunately, that vision is being kind of realized in, for example, in the Open Telemetry Ecto and Phoenix libraries. So let's use these two libraries and see what we can get. Save. OK. So let's just add them as dependencies. And we need to set them up. How we set them up, they actually use the telemetry system to get information about Ecto queries and Phoenix action calls. So we will set that up in the application module around here. It looks about right. We set the Ecto one with set up with the telemetry prefix the repo is using. And the other one just set up. And it should start listening to stuff that's happening. So let's kill this. The make steps get. Sorry. It's going to compile a bunch of stuff. You see it's compiling the Open Telemetry, all kinds of apps. No spans for now, but if I clock in, yes, I'm going to get this, which is basically a dump of the data that Open Telemetry collected. Okay. So here we see a span, for example. There's some numbers. There's even an undefined thing. I don't know. And then there's like, you can even get to understand some of it, like DB type, SQL, probably some metadata, right? And there's actually a SQL statement here. Create table. So that's pretty neat, but you're not going to look for logs to kind of understand what's happening. You need that somewhere useful. So we'll send it over to Tempo for visualization. So tempo, I'll show you that. And so this is Grafana. It's running on port 5000. We have two sub-products in Grafana configured, Loki and Tempo. Loki is for logs. Tempo is for traces, right? So Tempo will get a trace and will visualize the trace using Grafana. Unfortunately, Tempo uses the Open Telemetry protocol that I mentioned before. So we don't really, I won't be using the collector in my example. I'll be sending the data directly to Tempo because it allows that. Like, it understands the Open Telemetry protocol, which is kind of neat because they didn't need to figure it out again, and they basically used a solution that's available, you know? So first of all, I'll install the exporter. So an exporter, we used one already here, the std out exporter. But we're going to install a new, just add a new library, a new exporter, the Open Telemetry exporter that's basically exporting data in the Open Telemetry protocol. One thing I noticed that we need to set up is to configure the resource name. So the resource is going to be the service, basically, right? So we're saying that the thing that we're monitoring here, observing here, is a service with the name CMS. So we're going to configure that for everybody in the main config file. OK. And then we're going to configure the exporter. And this config is a bit weird because the exporter is an Erlang library. So you'll see that we're configuring it, the OpenTelemetry exporter for the batch processor. And we're configuring it with endpoints. Let me just close this. With endpoints, and it's an HTTP endpoint, and it's localhost, and it's 55681. That's because this is the port used by Tempo for the OTLP protocol. Okay, it's weird because yeah, it's using char list. So you don't use them very often in Elixir, but in this case, we need to use a char list, and it has this weird format. So maybe that's something that needs to be, you know, nicer to configure. I don't know. But anyway, if we try to save it and we get the deps and we run the server and we'll preview the logs for Tempo, it's going to compile a bunch of stuff. So it's compiling gRPC box, for example. So the Open Telemetry protocol, as I said, it's gRPC. It's well, it's protobuf, but it's using gRPC to send the data. So hopefully, if I run this and if I clock in, maybe let's do something else. Maybe let's go here. Sorry, not here. To the egg inventory, and let's add a new egg. OK. So hopefully, if you go to Tempo now, yeah, we'll start seeing these logs. And this is because I've configured Tempo to just log out everything it receives. So as you can see, it started receiving traces, which is kind of neat. So let's get this trace ID. And let's put it here. Blow up. Ta-da. So you can see a trace in Tempo. And this trace, what it tells us that it took 130 milliseconds to process. It was for the eggs endpoint. There's a bunch of spans here. So these are spans, right? The units of sub execution within a trace. So we have some query traces. That's really neat. That is available because we've installed the OpenTelemetry Ecto library, and that's instrumented out of the box. So we get this trace, this create table trace out of the box. And then we got this trace, for example, which is, it takes a bit more time. This is the insert statement, see? Insert into eggs. So we can see what kind of query or what kind of thing caused, for example, an unusual spike in execution time or something like that, right? Or if you see a very slow endpoint, you can dig deeper into what's actually happening there. So that's cool and all, but I don't want to kind of view Tempo logs to actually find the trace IDs. So what we're going to do is we're going to add the trace ID and span ID to our logger. So our app spills that out. And there's fortunately a library for that as well. So just add another library. It's good. It's like, did I click stop share? No, I'm sharing. OK. It's good because it's modular. Like, you can install the stuff that you need. You can skip the stuff that you don't need. So that's pretty good. And then we'll configure it in the application callback as well, like this. And so this will, the OpenTelemetry logger metadata is going to add the trace ID and span ID to the logger metadata. But then you need to whitelist that metadata, basically. You need to say, OK, this is allowed. I want to display this metadata. So we're going to configure that. In the config file, we have this console logger configuration here. Let's just configure. OK. Let's get the deps. And it's got to be there. Yeah, it's there. Never retype a command if it's in the history. Just press arrow up. So now if we go here, you're going to see trace IDs appearing here, right? And we even should be, yeah, there's an update trace ID here. We can copy that, go to tempo, and again, click, and we get the trace. Pretty cool. But that's not enough. Like, I want to see logs. I want to click on a log, and I want to get to tempo somehow. So that's possible in Grafana, which is pretty cool. To do that, we need to connect Loki and tempo together. We need to move our app back to Docker, actually, because my Docker is configured so that all logs from all the services are pushed to Loki. So to do that, since our app is built as a release, I need to give it some configuration. So we need to extend the compose file. So the CMS app needs to know where tempo is before we configure that in localhost. So that's one thing. And then the other thing we want to do is configure the releases file, which is responsible for loading configuration upon starting a release. Here. So this is sorry for pasting the code. I wouldn't make it in time without this. But it's basically getting these two variables, environment variables, checking if they are set. If they are not set, it's not worth configuring anything. Parsing one as a char list, parsing the other as an integer, plugging it into the exporter. OK? So that's pretty neat. So now when we build this, so let's exit here. And let's build DKCB, that's Docker Compose build. Let's build the CMS app. It's fast because I got it cached, so don't worry about that. It's going to take longer for you. We can kill this. We don't need it. So the app should be up in Docker Compose. It's up. So now if we go here, it's in production because we don't get the live something. And when I clock in, and we go to Loki, and we select the service, and we show us logs for the past 15 minutes, I don't know. We should get this trace, for example, time tracking, right? So let's set this to refresh every 5 seconds, and let's click clock in again, and we should get new logs. Boom. So we got this endpoint time tracking, and fortunately, like, you can configure tempo and Loki to talk to each other. And you can configure that a specific field is a link to the other app, to tempo. So I've pre-configured this, that a trace ID metadata field is going to link to tempo. So now, if I click here, that's going to screw up the layout, but you'll see the trace. So you can kind of click here, click there, and you see the trace. So it's very easy to get to it, right? But that's not all. Like, this endpoint, it's actually taking 18 milliseconds in production. Why would it take so much? Like, if I check the other things that we have here running, they take like less than a milli, like microseconds or something, whatever is that. So why is this taking 18 milliseconds? I don't know, because I don't see anything here, because it's going to a different service. So let's quickly add distributed tracing. Like, that's easy. So to do that, I actually had a snippet of code, but I extracted it to this library. So you can go to my repo and kind of see, so we don't need to explain it now. But it's basically a middleware for Tesla. And it's going to start a trace when a Tesla event, when a Tesla request is happening. And it's going to send the trace propagation headers with that request. So there are specific headers that you need to send in your HTTP requests for the other app to understand that this is just a part of a bigger thing. This is part of a bigger trace. I'm a microservice. Unfortunately, I'm not the most important thing. But yeah, you need to send those headers. And all you need to do is in the Tesla client, just add this as another middleware for Tesla. So we'll stop both apps. We need to rebuild the CMS app. We'll start both apps. Should be running. What the clock? Let's clock in. Let's go to Locky, CMS, and last 5 minutes. So for hopefully, if I click on this and I didn't screw up anything, I should see a distributed trace. Voila. So you can see that the trace went into the CMS service. Sorry, I just reset. And then it went further. So it went into, did the clock in request to the other service. And then in that service, in the time tracker service, as I said, it's already instrumented. So it went through different middleware. Those are like Express middleware. And then you can see that there's this piece of code here that's taking so long. It's taking 15 milliseconds. Do work. So whatever we need to do, we should first optimize this function, nothing else. Like this is taking the most time of this request, right? And we wouldn't know that without distributed tracing. Okay? So that's for the demo. Let's jump back into the hype time. Okay. Let's jump back into here. Where are we with OpenTelemetry? So we have a bunch of libraries, as you saw. A bunch of instrumentation is ready. I focus mostly on tracing here. I know that. Sorry for not covering the full spectrum. But the truth is, tracing is working the best in OpenTelemetry at the moment. Metrics are, I think, in alpha. Yeah, I didn't dig into those. For metrics, we have a pretty good ecosystem around telemetry anyway. Like at Fresha, we're using telemetry together with the statsd exporter for the telemetry, and that works pretty well. And you can export it to Prometheus, visualize it in Grafana, or you can export it to, as in our case, to Datadog, and that works fine. So there are solutions, other solutions. For tracing, it's just that there hasn't been something like this. Like you needed to buy into a specific app, right, or a specific observability solution before. So that's pretty neat that you don't need to do that anymore. Logs, on the other hand, like there are so many ways to send logs. Like if you're running in Kubernetes, you got a lot of integrations for Loki, for example, to scrape the logs into Kubernetes. So I think that's the least concern in the in OpenTelemetry's kind of roadmap. So yeah, I would recommend this for tracing. For that, it works pretty well. Metrics, maybe use telemetry for now, and then that will help you integrate into OpenTelemetry once that ecosystem is more stable. Logs, probably other solutions are better for now. Special thanks to the people that made this happen. So I'm just shining light on this project because I find it really exciting. But yeah, I wanted to thank Tristan Slaughter, I don't know if he's watching, for working on this tirelessly. He's been working on, I think, the Open Census project before, and the entire Erlang ecosystem foundation observability group who are building services around observability. Without them, it wouldn't be possible. And it's also, like, as I said at the beginning, my kind of goal is to inspire you to try these things out in your services to kind of make them more popular and maybe help extend those libraries, extend them with basically instrumentation, right? So I imagine like if there are any libraries that process data in the background or something, those could be instrumented. That would be interesting to see traces from that. There's a lot of work we need to do to realize the vision, but I really think it's a vision that's worth pursuing, to have everything instrumented out of the box and yeah, to see what's going on in your applications without much hassle. So yeah, shout out to those amazing people. And that's all. Thanks. You can find me on GitHub and Twitter and my email. Sorry that I have a very long username, but I'm bad at nicknaming, so it's just my first name, last name. But you can reach me there. The repositories are in my GitHub account, and that's all for today.
Thank you. We have time for one question, if you have any.
I know this guy.
Yeah. Thank you for your talk. I have a question regarding the gRPC part, because gRPC is generally synchronous, and I was wondering if problems with communication with collector can affect the application.
Yeah. So at Fresha, we've used a different library called Spandex, and that was handling basically when you had a lot of requests, it would impact your application. Or sorry, not when you had a lot of requests, but when it needed to send those requests further, like to the collector, let's say, right? It would actually apply some back pressure for your requests, and they would kind of slow down. In OpenTelemetry, that depends on the processor that you're using. The batch processor, I think it aggregates the data in the background, and then it just tries to flush it out to the collector in time intervals, basically. So I don't think that can affect your endpoint performance. Possibly your memory consumption, right? Because it needs to aggregate for some time. So if you have just too many requests for your app, it's going to kind of impact your memory consumption. It's going to aggregate a lot and then try to push out a lot of data in one call or multiple calls. I don't know how that's implemented, to be honest. So I'm just guessing here a bit based on my experience with, for example, Spandex.
OK, we have one more in the app. Luca is asking, where is the telemetry data actually persisted?
As I mentioned, Open Telemetry, it just aggregates the data from your app. It fetches the data from the libraries that are instrumented, and then it sends it somewhere else. So you actually need a backend for that to visualize it. So in my example, I've visualized that using Grafana and Tempo and Locky. So this is where the data, the telemetry data is persisted. In this case, it was in Tempo. Tempo, I think I just configured it with a local volume with my computer. You can also kind of use other volumes to save the telemetry data in Tempo. And Locky is also like persisting the data itself. So that's where it's persisted. You need something else to send the data to and to visualize. And there are a lot of solutions. The nice thing about OpenTelemetry is that you can exchange the solution. So that's pretty cool. Like if you bought into an existing solution for tracing that required you to use a property library, it's difficult to get out of that. You are a bit vendor locked, right? But if you're using OpenTelemetry, then the backend that you're using for visualizing is pluggable. Yeah, like you can use one thing and then use another thing. You don't need to rewrite your application. So that's pretty cool.
Thank you.
All right. Thanks.